Unit 3, Boolean Expressions and If Statements. Topic 3.6, Equivalent Boolean Expressions. In this lesson, we will compare and contrast equivalent Boolean expressions. Equivalent Boolean expressions will evaluate to the same value in all cases. This equivalency was first discovered by Augustus De Morgan, who was a British mathematician. He devised two rules that can help us evaluate equivalent compound Boolean expressions. De Morgan's laws can be applied to Boolean expressions. His first law states that not A and B is equivalent to not A or not B. The second states that not A or B is equivalent to not A and not B. We can use these equivalencies to help simplify Boolean expressions and to express different logical expressions. When looking at these statements, it may not be obvious that these statements are equivalent. Let's take a look into how these are actually the same. In our last lesson, we said that truth tables help us visualize and analyze how logical operators work within Boolean expressions. We will use truth tables to help us see De Morgan's laws more clearly. Truth tables can be used to prove Boolean identities. The first thing we do when setting up a truth table is to identify the inputs and the Boolean expressions. The first two columns should be set up as follows. With this information, you can now start evaluating the Boolean expressions. A and B, not A and B, not A, not B, not A or not B. Notice how these two expressions are equivalent, proving De Morgan's first law. Distribute the not, flip the and operator to or. Let's look at the second law. The first two columns should be set up as follows. With this information, you can now start evaluating the Boolean expressions. A or B, not A or B, not A, not B, not A, and not B. Notice how these two expressions are equivalent, once again proving De Morgan's law. Distribute the not, flip the or operator to and. Let's focus on the not operator for a moment. Up until now, we have used De Morgan's law on Boolean variables. How might we apply the not operator to a Boolean expression? How might you express not x greater than 0? Or in other words, x is not greater than 0. Couldn't we say that x not greater than 0 is equivalent to x less than or equal to 0? How might you express not x less than 0? Or in other words, x is not less than 0. Couldn't we say that x not less than 0 is equivalent to x greater than or equal to 0? How might you express not x less than or equal to 0? Or in other words, x is not less than or equal to 0. Couldn't we say that x not less than or equal to 0 is equivalent to x greater than 0? How might you express not x greater than or equal to 0? Or in other words, x is not greater than or equal to 0. We could say that x is not greater than or equal to 0 is equivalent to x less than 0. What pattern do you notice in regards to the not operator and the relational operators? Distributing a not operator with a Boolean expression flips the relational operator to its opposite relational operator. Let's try a practice problem using De Morgan's laws. Based on his findings, how could we rewrite this expression? Distribute the not operator to both Boolean expressions and flip the or operator to and. When we distribute the not operator to these Boolean expressions, we flip the relational operators. Therefore, according to De Morgan's law, these two expressions are equivalent to one another.